NGC 4151, a prototypical example of the unified model of AGN. A black hole is an object that produces a gravitational field so strong that nothing, not even light, can escape from within its event horizon. Supermassive black holes are much larger than the stellar massive black holes that form when massive stars explode. Their method of formation is unknown, but it is possibly from the collapse of a dense star cluster. There is a supermassive black hole at the center of most galaxies. An active galactic nucleus, or AGN, is a galactic center that emits a large amount of radiation due to accretion around a central supermassive black hole. AGNs are classified into several categories: Seyfert galaxies, types 1 and 2, radio galaxies, quasars, and liner galaxies. The unified model attempts to explain the similarities and differences between these types. The active galactic nucleus is surrounded by a dusty torus that blocks most of the electromagnetic spectrum, preventing the accretion disk from being seen from the side. Seyfert type 1 galaxies are seen from the side, while Seyfert type 2 galaxies are seen more directly. AGNs are classified into radio quiet, which includes Seyfert galaxies, and radio loud, which includes radio galaxies and quasars. The difference between them is unclear. In this project, I will analyze in detail what is happening at the center of a galaxy. This can provide information about its structures. Using QFIT's view, I used to create composite images of the active galaxy NGC 4151 on a larger scale, then analyzed its spectra under different emission lines, and then created velocity maps for the galaxy. They analyzed spectra from OSIRIS of the Keck Observatory and created composite images from SDSS. These images demonstrate that NGC 4151 is a confirmation of the unified model of AGN. NGC 4151 is the Seyfert galaxy in the constellation Canes Venatici. It is known for its complex emissions in the narrow line region. This is a multi-wavelength, three-color image of the galaxy at a larger scale. The pixel scale is 0.39582 arcseconds. The disk is elongated with a very bright nuclear region, while it is more diffused near the edges with a spiral pattern. It is rotated 45 degrees from north. The colors are not actual colors, but they represent different wavelengths of light. Here is the central spectrum of NGC 4151. Here is the silicon line. This is just atmospheric interference. Here is the hydrogen line, and here is the calcium line. Here is the silicon line up close, and here is the calcium line up close. They are both highly ionized gases that only occur in active galaxies. Here is the ionized hydrogen line. Hydrogen is the most abundant element in the universe. This one has a broad line and a narrow line. Here is the hydrogen line of the molecular variety. It does not occur in the nucleus and is taken from a different part of the galaxy. Here is the emission lines for H2, the molecular hydrogen. The continuum map measures the continuous spectrum. It is showing that the nucleus of the galaxy is the brightest part, and it is the same at all wavelengths. This is the flux map. It shows the various gases distributed throughout the galaxy. It does not appear particularly bright in the center because there is no molecular hydrogen there. Here is the velocity map. The blue parts are moving towards us relatively to the green parts, which are moving away. This shows that the galaxy is rotating. The dispersion map shows various dispersed gases in these areas that form the dusty torus. This map shows the distribution of molecular hydrogen. Here is the map for ionized hydrogen. The flux map is similar to that of molecular hydrogen, but with a bright region in the center of the galaxy. The velocity and dispersion maps also look different. Here is the map for highly ionized silicon. Here, it shows the jets of ionized gas that are produced from the center of the galaxy. And here are the same maps for calcium. Here is an artist rendition of the dusty torus. It shows the dusty torus, the jet, and the actual massive black hole in the center and the accretion disk surrounding it. The actual images I have shown correspond to various parts of this picture. Thanks to Dr. Francisco Moller Sanchez for being my mentor to this project. Thanks to my mom for helping me put this together also. And here's the bibliography. End.